Hi, this is a material balance problem. In this problem, we are asked to find out the weight percents of the leaving streams of a bioreactor where Saccharomyces cerevisiae, which is also known as baker's yeast, carries out the biochemical reaction converting glucose to ethanol and propenoic acid. We are given the concentration of the inlet stream, the total mass of the inlet stream, the gas, carbon dioxide, which is produced, and the unreacted glucose. So with this information in hand, we've got to find out what are the exit streams concentrations. So the first thing to do is to draw a flow diagram. So we've got streams coming in and 5 streams coming out: glucose and water, and similarly glucose going out, water going out, carbon dioxide, propenoic acid, and ethanol, and all these are out. I'll put the suffix O and the suffix I for the inlet. The total mass is 4,000 for the inlet stream. That means the total mass for the outlet stream has to be 4,000. Glucose is 12%. That means water has to be 88%. So with this information in hand, let's construct the mass balance equations. First one to do is the mass balance for glucose. So glucose in minus glucose out plus anything which is generated minus anything which is consumed has to be equal to 0. Why 0? It's because we are dealing with steady state and there is no accumulation. So glucose in, we've got the mass. And when you have reactions, it's much better if you do the calculations in moles, because the reaction relates numbers in terms of moles through the stoichiometric coefficients. So 4,000 multiplied by 0.12 divided by 180. So that's going to be the moles of glucose coming in. The moles of glucose coming out is 90 kilograms, which is coming out, divided by the molar mass of glucose. Nothing is being generated in the reaction. No glucose has been generated, but it's been consumed via 2 different reactions. So let's call that Xi1 moles got reacted through the first reaction and Xi2 got reacted through the second reaction. So when you add them up, it has to be equal to 0. So if you do the calculation, you'll see that Xi1 plus Xi2 is going to be 2.17. So that's the first equation you've got. So similarly, you can now list the second and the third and the fourth equation. The second equation I've got is for carbon dioxide. There is nothing coming in, but it's actually going out as 120 kilograms, and the molar mass of carbon dioxide is 44. And it's generated from the first reaction here. We wrote it here, and we said that the first reaction, Xi1 moles react. That means 2 times the Xi1 moles of carbon dioxide must have been formed, and nothing is being consumed. This has to be equal to 0, and from which we can get Xi1 should be equal to 1.36 kilomoles, and these units are in kilomoles because we've got kilograms. So if you know Xi1, then we can calculate Xi2. That's going to be 2.17 minus 1.36. That's going to be 0.81. So we've got Xi1 and Xi2. And similarly, we can write 3 other balances, one for water, one for propenoic acid, and another one for ethanol. So the water, it's coming in, which is 4,000 times 0.88 divided by 18. That's going to be the moles of water coming in, and it's going out, which we don't know how much it is, and it's generated through the second reaction. Nothing is being consumed, and the second reaction, Xi2 moles react, and I can see here that 2 times Xi2 moles of water would have been formed. So plus 2 times Xi2, there's nothing has been consumed, has to be equal to 0. So from which, plugging in the value of Xi2, we would get the water out. We've got the water coming out. So we know the carbon dioxide. We only have to know the mass of propionic acid which is coming out. Then we can calculate the weight percents. So now propionic acid. It's produced in the second reaction. Nothing is coming in and it will go out in proportion to the moles of side 2 which has reacted in reaction 2. So propionic acid, nothing is coming in, so that's going to be 0. Out, that's what we're going to find out. And it's been generated through the second reaction, and the stoichiometric coefficient is 2. That means 2 times the side 2 moles would have been formed. And nothing is being consumed, and that's to be equal to 0. That means, and finally, we've got ethanol. So if you do the ethanol is present only in the first reaction, and psi 1 is the moles reacting in the first reaction. So we can say for ethanol similarly, there is nothing coming in minus ethanol out should be in proportion to this amount. That means ethanol out should be equal to 2 times the psi 1. That means, so now we've got the moles of all the components of the exit streams. So it's just a matter of converting it to mass and finding out the final composition. And some of you made a mistake here, which is you did not exclude carbon dioxide. Carbon dioxide is a gas which goes out, it doesn't stay in the liquid. So when you calculate the weight percent, so it's sufficient to calculate in terms of the total mass excluding the carbon dioxide. So when you do that, you will actually find out. So what can we say about the selectivity? That means they are more or less, they are equally preferred by Saccharomyces cerevisiae, because the weight percent, they are almost the same. So this is an example of a mass balance problem solved using the extent of reaction method.